Water shuttle operations and relay pumping operations are two methods of providing water to emergency scenes in remote areas. Each method has its advantages and disadvantages, but the method used by a fire department usually depends on the type of equipment that it has available and tradition within the department. In this program on water shuttle and relay operations, you will see basic information about each type of operation. The training objectives are to describe a typical water shuttle and show the equipment involved, to show basic procedures for setting up a water shuttle, to describe a basic relay pumping operation, and to present the process for setting up a typical water relay. Water shuttles are simply operations where water is collected at a source, then transported to the emergency scene, where it is unloaded and then used to supply fire attack lines. The two primary types of apparatus required to operate a water shuttle are pumpers and tenders, which are also called tankers. An effective water shuttle will require a minimum of 2 pumpers, one at each end of the shuttle. One pumper will position at the water supply source and will be used to fill the empty tenders. The water supply area is called the fill site. The other pumper will position at or near the emergency scene and will draft water from the portable water tanks to supply attack lines. This area is called the dump site. Fill site pumpers should have a pump capacity of at least 1,000 gallons per minute, or about 4,000 liters per minute, because NFPA 1901 requires tenders to be designed so they can be filled at a rate of at least 1,000 gallons per minute. Efficiently designed tenders or tankers are key to the success of the water shuttle operation. Tenders must carry at least 1,000 gallons or 3,785 liters of water, according to NFPA 1901. Most tenders carry 1,500 to 3,000 gallons, or 6,000 to 12,000 liters. The water tank should also have tank vents to allow air to escape during quick filling and to equalize the pressure in the tank during dumping. Always make sure that the tank vents are completely open during filling and dumping to avoid a disastrous tank failure. Tenders that are just used for water shuttle do not need a fire pump if they have an effective gravity dump system, but most departments do specify some type of fire pump on their tenders. Although NFPA 1901 requires only one large tank discharge, usually called a dump valve, it is best if the tender has at least 3 dump valves, one at the rear and then one on each side. The success of a water shuttle requires good decision-making before the operation begins. Crucial decisions include where to put the dump site, where to position at the fill site, and the travel route between the two places. It's always best to plan these decisions during pre-incident planning when you're not under the pressure of responding to the emergency. When selecting the dump site, remember, it may not be best to locate it close to the incident. If you have a long driveway or dead-end street, it would be best to locate the dump site where this dead end intersects with a thoroughfare. Even if the incident is on a through street, it may not be possible to locate the dump site right in front if other vehicles are blocking the way. Consider a close-by intersection or parking lot where the dump site pumper could supply water to the emergency scene. When considering the fill site location, remember that fire officers and driver operators should have prior knowledge of all the hydrants and drafting locations in their response district. In the heat of battle is not the time to go looking for a water source. For reasons of travel or water flow requirements, you may not want to choose the closest source. To lessen the chance of an accident and to speed up operations, try to pick a location that requires the minimum amount of backing or maneuvering of tenders. When selecting the route of travel, remember that driving the shuttle route is one of the most hazardous tasks for the tender driver. Consider safety as well as efficiency. A circle route is the best way to design a water shuttle operation. If you can use a circular pattern, you will avoid backing up, and trucks will not be passing by each other on narrow roads. Other safety issues to consider when selecting a route are narrow or winding roads. Remember that tenders passing by other vehicles could be a problem, especially if your tires get off the roadway. Long driveways. Avoid tight maneuvering or situations where apparatus must approach from opposite directions. Blind curves and intersections. If vehicles cross the center line, or if civilian drivers cannot see apparatus approaching, it's an accident waiting to happen. Steep grades. Whether it's uphill or downhill, it's tough on you as well as your engine and brakes when you're carrying thousands of pounds of water. Bad weather conditions. If the road has snow, ice, mud, or storm debris, avoid it. If possible, close down roads to all traffic except emergency apparatus during shuttle operations. If this is not possible, exercise extreme caution, as the public may be confused and curious about the presence of fire apparatus in the area. While water shuttle requires speed to be efficient, remember that driving a tender too fast is not the way to save time. Pre-planning and practice with the operation is the safest way to increase efficiency. Tender drivers should always keep speed to a minimum. Setting up a water shuttle operation always begins at the fill site. The fill site is commonly a fire hydrant or a static water source. It is recommended that to maximize flow, you use a pumper at the fill site to fill tenders, whether you are using a hydrant or a static source. At a hydrant, position the pumper and connect a large diameter intake hose between the large pump intake and the steamer connection on the hydrant. If the hydrant is on a strong main, you may also want to connect a second line to another outlet on the hydrant and use an additional intake on the pumper. When positioning at draft, find a spot that requires a minimum amount of lift or hard intake hose. If it's impossible to position the pumper at the draft source, you may be able to use high-volume portable pumps to relay water to the pumper. Whatever your water source, be sure to flow a small discharge line from the fill site pumper to make sure you do not lose prime when operating at draft, or to avoid overheating the pump when operating from a hydrant. When your water source has been secured, you need to position tenders so that a minimum amount of hose is required from the pumper to the tender. Also remember that the ideal positioning of tenders is so they will be able to drive straight out after filling. Set up a cone or other marker as a target for the tender driver operator to aim for. When the tender stops, the cone should be next to the driver's door. If the tenders have two 2.5-inch or 65-millimeter direct tank fill connections, lay 2 medium-diameter hose lines to the point where the rear of the tenders will part. The larger the hose diameter you use, the better it will be. Put a gate valve between the last section and the second to the last section of hose. Hose clamps can also be used. When you are ready to begin filling, a firefighter should be assigned to each tender fill line. These people are called make and break personnel. They make the fill connection and then disconnect the hoses when the tank is full. While the filling is going on, the tender driver operator should remain in the cab at all times. When the tender is full, the hose connection can be broken and the tender can immediately drive away and another take its place. At the dump site, there are 3 common methods for getting water from the tenders to the hose lines: direct pumping, nursing from tenders, and portable tank operations. Tenders with pumps can use direct pumping or nursing from the tender to provide the water needed. If your shuttle tender does not have a pump, one of the most efficient methods is to use portable water tanks. The first tender dumps its water into the portable tank. Now the dump site pumper may immediately begin supplying water to the emergency scene by drafting from the portable tank. If you are lucky enough to be able to locate the portable tank right next to the fire scene, the attack pumper may draft directly from the tank. A relay pumping operation is described as a pumper at the water supply pumping water under pressure through hose lines to the next pumper in line. That pumper, in turn, pumps to the next one, and so on until the water reaches the emergency scene. Relays are used when the water source is too far from the emergency scene to supply enough water under enough pressure to adequately supply hose lines. The apparatus and equipment needed to establish an effective relay are pumpers for source, relay, and attack, and medium to large diameter hose. There are a variety of hose and pump appliances that may be used to assist in a relay. They include intake pressure relief valves, in-line relay valves, and discharge manifolds. Before you can determine what type of relay to establish at an emergency, you need to consider two important variables. First, the amount of water needed, and second, the distance from the water source to the emergency scene. In some situations, the relay will be supplying all of the water needed to fight the fire. In other cases, it will be used to supplement an inadequate water supply system. Let's look at the process for putting a typical relay operation into place. Always begin with the source pumper. As a general rule, always use your largest capacity pumper at the source. Remember that the maximum capacity of the relay will be determined by the capacity of the smallest pump and the smallest hose line in the relay. In other words, the weakest link in the chain. You do not want the chain to be weakest at the source. Once the water supply has been established, open an uncapped discharge or flow water through a dump line until the first relay pumper is ready. Build up the discharge pressure by increasing the throttle and slowly closing the dump line discharge valve so you don't waste so much water. The relay pumper should have the discharge or dump line open and the pump out of gear. When both the source and relay pumpers are ready, slowly open the source pumper discharge supplying the relay hose line. Now, the water is moving through the hose line to the relay pumper. The air in the hose will move through the pump on the relay pumper and out the open dump line. When you see water pouring out the dump line of the relay pumper, it's time to engage the pump. It's best to maintain intake pressure in the relay pumper at less than 50 psi or 350 kilopascals. You can adjust the pressure by adjusting the dump line valve as necessary. When the next relay pumper is ready, the same procedure will be followed and repeated with each relay pumper until the water reaches the attack pumper. At the attack pumper, the operator should bleed air out of the supply line by opening the bleeder valve on the intake being used. Open the intake valve on the attack pumper and the water supply will be established. It's not necessary to use the dump line on the attack pumper when receiving the relay water as long as attack lines are flowing. A dump line should be used if it will be necessary to open and close the attack lines from time to time. Once the relay is in operation and water is moving, all pump operators should set their automatic pressure control devices to an appropriate level. There is a tendency to overreact when operating in a relay. You should expect small variations in pressure. It's not necessary to be exact, and it's best to just leave things alone unless you see the intake pressure dropping to less than 20 psi or 140 kilopascals, or higher than 100 psi or 700 kilopascals. Shutting down the relay should always start at the fire scene. Starting with the attack pumper, each operator should slowly decrease the throttle, open the dump line, and then take the pump out of gear. Once all of the pumpers are shut down, you can drain the hose and get it ready for reloading. In many jurisdictions, you do not have an adequate water supply at all the occupancies you protect. You may need to bring water in from a remote source using water shuttle or relay operations. In this program, you have seen the basics of these operations, including a description of a typical water shuttle and the equipment involved, and the basic procedures for setting up a water shuttle. You have also seen a basic water relay operation and the process for setting up a typical water relay. Water transport operations add another layer of hazard and complexity to any firefighting effort. And the driver-operator plays a crucial role in making sure that each of these operations runs safely and efficiently. You will be part of a coordinated effort that requires everyone to work together and know their job. Training and drilling is critical to be certain that you can get water from there to here in the quickest, safest way possible.